Hello guys, I hope I find you well today. Okay, so what I want to say here today is we are going to be looking at factorization. That's the topic, and I have gathered 4 questions or 4 examples that I'm going to use in trying to help explain what we do through the methods and the procedures of each method when factorizing. So what I'm going to do here is to give you the breakdown, and then we'll move in to find what different rules are we going to be applying. If you're new to this channel, do not forget to be part of the family. Then do the right thing by just clicking the subscribe button and hitting the notification bell, so that whenever we upload content, you can get it while it's still fresh. Okay, so I don't want to waste much of your time. I know this topic is going to be long, but I'll try my level best to make it very, very short. So let me not waste much of your time. Let's jump into the topic. Okay, so in introducing this topic, I just want to let you know that there are going to be 4 methods that we are going to be using to solve or to simplify expressions like this by factorization. So let me just give you these in breakdown. The first method is what we call factorization by ACF. The second method is factorization by grouping. The third method is difference of 2 squares. And the fourth method is quadratic factorization. I hope you did understand. We have 4 methods. So meaning to say these methods are going to be operated according to their own rules, whereby I'm going to be introducing the rules as we'll be factorizing. So it is very important for you to check the question and try and match it to the method. It is very important, guys, because you can't factorize a quadratic expression using factorization by ACF. So it is very important for you to know how do we discern whether this question is quadratic, is difference of 2 squares, or is factorization by grouping, or is factorization by ACF. So more of those things I'll be just explaining as time goes by, so just stay tuned and be listening, okay, as the topic is going on. So the first method that I'm going to introduce at this moment is what we call factorization by ACF. Okay, the how you know whether it's factorization by ACF, do not worry about it. What I want to say is factorization by ACF is the primary method of factorization, whereby before attempting any question, you must first test whether it can be factorized by HCF or not. So it is a must that you test every question whether it can be factorized by HCF before you attempt it. Right, so trying then to explain the stages of factorization by ACF, I have got the question 1 on the screen, which is reading 15 MK plus 21 MB minus 12 LM. Let's see how do we factorize this thing together. Okay, so to try and show you how do we do factorization by HCF, the question is on the screen. Now let me put the rules also on the screen so that you can find it easy. So the rules of factorization by ACF are these ones. Please make sure that you know and remember these rules. Do not forget them. Rule number 1 is saying take out the HCF. Rule number 2 is saying divide every term by the HCF, putting any remainder into the brackets. You may not understand it. Let me now present it. So meaning to say, applying rule number 1 to this question, we would find out that the HCF of everything here, the HCF of 15, 21, and 12 is 3. HCF of MK, MB, and LM, I think is rhyming MMM, meaning to say it's M here. And then now we open a bracket. We are done with taking out the HCF of the whole function. Now, having this procedure done, we are going to move to second stage, which is saying divide every term by the HCF. Let us now do it. 3m into 15mk, 3 into 15 is a 5, m into mk is a k, 3 into 21, positive 7 here, and then m into mb is a b, and then 3 into negative 12 is negative 4, and then m into lm is l, and then we close it. So this is how we simplify this question, and it's done. Just imagine, it's very simple. As simple as this, you are done with factorization. Okay, so now trying to do the second type. I have got the question on the screen: 3ax minus 6bx plus 5ay minus 12by. So now this question, I'm going to use it as an example of how do we factorize using factorization by grouping method, which is method 2. Okay, now let me just also give you the rules. The rules are: number 1, you break the terms into pairs of 2. Let's do that first before we go any further. All right, breaking everything into those terms, or into pairs of 2. So meaning to say, my first pair here is going to be including term number 1, 3ax, and term number 2, 6bx. The second pair is going to have plus 5ay and minus 12b also. So you'd find out that now I have grouped it or broken this expression into a group or into terms of 2. That's the first stage. The second stage now is saying factorize each pair on its own using factorization by HCF. Okay, I'm very sorry, it's not coming right here. Okay, so what I'm going to do is to use factorization by HCF to simplify these guys. Let's do that. Meaning to say, the first part, if I use factorization by HCF, what do I get? What is the HCF of the first pair? 3ax minus 6bx. You are right. The HCF I'm finding here is 3 is common, and then x is common. Okay, then after that, what are we going to do? To open bracket, let me just introduce also the rules for factorization by HCF. It is now saying divide every term by the HCF, putting the remainders in the bracket. So 3x into 3ax, you're left with a, and then 3x into minus 6bx, you're left with minus 2 and b. Okay, let us deal with the second pair here. What is the HCF? HCF of this, I have 5a and this. Okay, let me check if it is the perfect question. All right, okay, it's not 5ay, it's 6ay. Okay, thank God we saw the mistake early. So what you're going to do here is to find also what is the HCF of this. So what is the HCF of 6ay and 12by? All right, we bring down the positive sign here. We see that 6 can get into both sides, and then y is also both sides. Okay, we open here. Now 6 into 6y into 6ay, we are left with an a. And then 6y into minus 12by, we are left with minus 2 and b. This is factorization using the rule of factorization by HCF on each of the pairs. All right, so now we are moving to the third stage, which is saying now take out the highest common bracket. Okay, it's very fun to say highest common bracket, all right, but it's just for you guys to understand. In other words, this bracket is exactly the same as this bracket. Okay, so this means we can say the highest the bracket itself is the highest common factor in this regard. So let us take that out the same way we have taken out the HCF in that rule. Let me just repeat, put on the screen these rules. So if we take this bracket as the highest common factor, we put it here aside as a minus 2b. Okay, now what you're going to do, if this bracket is to be divided into these on the top, you'd find out that bracket cancels this one, and then you're left with terms outside the bracket. So what you can do is just to take the terms outside the bracket as your remainders. That's what we do. Very simple. Okay. In other words, if you don't understand, if you want the reason why I took the terms outside the bracket, you just follow the rule which is saying divide every term by the SCF, which is the bracket. So if you divide by the bracket, you'd find out that the bracket cancels the bracket, you are left with 3x. The bracket cancels the bracket, and you are left with 6y. Okay, sorry, yeah, it's 6y. I closed the bracket very early here. I must put also the y, which is 6y, like this, and then we close it. Okay, let us quickly jump into the third method of factorization, which is called difference of two squares. Okay, so just jumping into this, we are going to be looking at the rules first. So the rules are simple. They are saying all right, let me just remove also these and these. Okay, so the rules are saying express everything in power 2. That's the first rule, if it is difference of two squares. So how do you know that this is difference of two squares? Let's say you have tried, the thing here about these methods, they don't work together. It's more like if a question requires difference of two squares, you can't use any of the other three. So what you do is to look at the question and try, is it possible for you to use factorization by SCF? If SCF fails, you try factorization by grouping. If factorization by grouping fails, you try difference of two squares. That's how you do it. You just go step by step. You are just analyzing the question to try and figure out which method works according to the question that you have. Okay, so here now this question is a type of difference of two squares. So what we do is the rule says we must express everything to power 2. So 25 can be written as 5 to the power 2. A is already in power 2. Minus 16 can be written as 4 to the power 2. And then B is already to power 2. Alright, so the first stage is done. We go to the second stage, which is saying ignore powers and form a bracket of the bases. Meaning to say I'm going to ignore these powers and form a bracket using these bases, okay, that I have. So let us do that quickly. We will have 5a minus 4b in bracket. Okay, but then third stage is saying rewrite that bracket, but this time replacing the minus by a plus. So we open another bracket and rewrite it as 5a minus 4b, and then now we are not going to put a minus, we replace the minus by a plus. Then we are good to go. This is how we factorize difference of two squares. I believe and hope that you guys have understood how do we do the thing of difference of two squares. Alright, now allow me to introduce the fifth method of factorization, which is known as quadratic factorization. Okay, in quadratic factorization, what you're going to do here is very simple. We are going to look at this question, which is written k squared minus 9k minus 36. Okay, so this video is going to, just forgive me, okay, because there's some kind of interruptions here. So we are going to be looking at this question in trying to also show the stages through quadratic factorization. All right. So what you're going to do is very simple here. We are going to project as usual, okay, the questions, the procedures. Okay, so we have procedure number 1, which is saying multiply end terms. I want you to listen very carefully. This one is a little bit tricky. So we are going to multiply end terms. What are the end terms? This one and this one. So what is the answer when you multiply k squared and minus 36? Right, so the answer becomes minus 36 k squared. That's the first stage. Now the second stage is saying find the factors of that product, okay, which can add or subtract to give the middle term. So we want to find what are the factors of 36 k squared that when we multiply them they give us 9 exactly. Okay, so just because today we are having a lesson, let me just show you what you do. What you do is you try 1 and 36, you try 2 and 18, you try 3 and 12, you try again, I think 4 and 9, okay? And then is there any other factor? Okay, there is also 6 and 6, okay? So this is what you do. Now let us look at these factors and see how are they going to give us the middle term, which is 9. Okay, that one is easy. I just want to show you something. Because here 36 is a negative, okay, it shows me that these factors are not going to have the same sign. One is going to be positive, the other one is going to be negative, because the rule says that when the signs are different in multiplication we get a negative there. All right, and then after that, so meaning to say we don't know which side is going to be positive, which side is going to be negative. We have to consider now the middle term. Since the middle term is negative, we put that sign to the large factors, which is negative, 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 and negative. So these ones are now negative. Now, because we did put negative sign, we now put plus here because we know that the signs should be different, okay? Fine. So this is the first stage. Let us look at these factors and see which one are going to give us 9 or which ones are going to give us 9. So 1 minus 36 is not 9. 2 minus 18 is not 9. 3 minus 12 is negative 9, 100%. You can test also this one is 0. So you find out that this one gives you about negative 5. So you find out that the rest will not work. There's only one that can give you negative 9. So this is how we get it, okay? So what you're going to do is the factors that you're going to deal with are positive 3 k times negative 12. Okay, k. So in other words, we are writing negative 36k squared in terms of its factors. That's it. We are done with this stage. Now, the third one is saying replace the middle term by those factors in the original expression. So let us look at it. Meaning to say the original expression is reading k squared minus 9k and then minus 36. But the rule is saying we are going to replace this middle term by the factors we have found here. So what does that mean? This means I'm going to write k squared, not 9 here, but now plus 3k minus 12k and minus 36. You know, putting these two is as good as putting 9k because they can add and subtract to 9k, right? So what you're going to do when we are here is to do what you call factorization by grouping, because it is the fourth stage, which is reading factorize using the rules of factorization by grouping. So let us do that very quickly now. Okay, so the rules of factorization by grouping are here, and let me remove these rules, okay, and put the factorization by grouping here. So here factorization by grouping is saying what? Now break into pairs. Let us now do this quickly because it's revision. So what you're going to do is the first pair is what? Okay, so the first two parts are k squared and 3k, and this one and this one. So let us do that quickly. K is common, open brackets, here put a k and then a plus 3, okay? I wish you guys can do it and continue using factorization and the rules of factorization by grouping here, right? I think it's wiser if you can do it that way, then we'll do it. Okay, let's go. So what you're going to do is here, we take out also negative 12 is common, and then we are left with k plus 3. Now what is the highest common bracket? Is k plus 3 and what are we left with? K minus 12. Okay, so this marks the end of the story. I believe you have, understood it also very well. Okay, so guys, just forgive me here. I'm recording from home. There is a lot of interruptions, disturbances. I was supposed to be looking at those advanced questions, and I was having them, but I can't just move on because I can see that will end up destroying or spoiling the whole video. So if you are interested in seeing the other part, I think I'm going to record those on a separate note also and upload on this channel. So stay tuned, stay subscribed, and being part of the family. Let's meet next time. Sharp. God bless you.